So, ladies and gentlemen, today we're going to do chapter 10.5, Rationalizing Radical Expressions. You guys are excited, I know, right? So again, we're going to show you some rationalization techniques to simplify these things, okay? And it says goal number 2, determine the product of a conjugate and simplify quotients involving radicals by rationalizing the denominator. I'll explain what that is on the back side.
Oh,
okay.
I remember those.
Yeah. All right. So let's get started here. So I got example 1. I got 1A through H, and again, we'll do the ones that we need. I don't think we'll do all of these. I'm not going to make it super tough on you guys when we rationalize. So put your phones away. You guys don't need them. Earbuds, yeah. You guys with your earbuds, put those away. First thing I do is if I see a square root of a fraction, I always like breaking it down as the square root of the numerator over the square root of the denominator. So far, so good? So if I have the square root of 1/2, I'm going to make that the square root of 1 over the square root of 2. Now, one of those I can simplify. I know that the square root of 1, I know what that is, right? What is that? What's the square root of 1? Just 1, and then I have root 2. Now, this is where a math teacher starts shaking a little bit. Okay, they don't like seeing the square roots in the denominator. Okay, we want to simplify it. We want to rationalize it. It's like an English teacher when you guys are writing letters to your friends and you don't capitalize anything, right?
Like, no.
Like I, the letter I should be capitalized, and like your name and all that stuff should be capitalized. And when an English teacher sees that and you're not capitalizing things and not using punctuation, they're freaking out. Okay, well, Mr. Gotch is freaking out. We want to rationalize the denominator here. Okay, now to do that, I'm going to multiply top and bottom by the square root of 2. Okay, and here's why. What's the square root of 2 times the square root of 2? It's just 2. It gets rid of that square root. And then 1 times the square root of 2 is just root 2. So I always say if you leave it like this, if you leave it like that, you're a dirty rat. If you leave it like that, you're a dirty rat. And it's not because you're a rat, it's because I want you to rationalize it. To rationalize something means to get rid of the square root in the denominator. Okay?
So it can be in the numerator.
It's okay to be in the numerator, we just don't want it in the denominator. Okay?
And why is that?
Why is what? Why do we not want it down there?
Yeah.
It's just improper. Okay, we want to be proper. It's like, again, in English class, we capitalize. That's improper to uncapitalize stuff. That should be capitalized. It's just not proper. Okay? All right, so let's take a look at B. This one's already set up. I've got 15 over root 3. Okay? This is making Mr. Gotch shake a little bit. Okay, I can't stand this. I need to rationalize it. So I need to multiply top and bottom by what? What's on the bottom? Root 3. So I'm going to multiply top and bottom by that square root. Okay. And 15 times root 3 is 15 root 3. And then what's root 3 times root 3? It's just 3. The idea on this, guys, is it's root 3 times root 3. Well, that's root 3 times 3. It's like 3 times 3, right? Or 3 squared. You need to square root something squared so it gets rid of that square root is the idea. So we need 2 of these 3's, 3 squared, so that it eliminates it, gets rid of it. Makes sense or not make sense? Okay. Now, if I leave it like this, it's going to be marked wrong. Does anybody know why this still can be simplified? We're almost done. Huh? Yeah, we can reduce here. We can reduce that. So 15 divided by 3 we know is 5. and then root 3. So final answer is 5 root 3. Bless you. I also teach pre-calculus right now. We're doing this a ton with trigonometry.
Boo.
I know, boo. But trigonometry is something you're going to see in geometry. Okay. We do a little trig in geom. You might have to rationalize in geometry. Okay. All right. So final answer, 5 root 3. All right. Take a look at the next one. Again, put your phones away. I don't want to take them. Give them your dean. Put them away. I take a look. I got 1 over root x. We got to get rid of that root x in the bottom. So what do I have to do? Just multiply by root x. Look at that. On top, I get 1 times root x is root x. And the idea here is this is now root x squared. And when I square root something squared, I get what's inside that's been squared, which is just x. So root x times root x is x. Okay, when you square root something squared, you get the base, you get x. This thing is killing me, man. Final answer, root x over x. So far, so good? So sometimes we got to do a little simplifying here. So I'm going to take a look at D. All right, so I've got 7 over the square root of 5x cubed. Now, technically, I can simplify this a little bit before I rationalize. So if I can, I'm going to try to simplify. If I take a look, the square root of 5, there's no pairs. But if I look at these x's, x, 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 I got a pair of x's here. So I got a pair of x's. This is really 7x. And then left on the inside is that 5 and this x. So the 5 is left in there, and then this x is left in there. So far, so good? Any questions of where I'm at right now? Well, I want to rationalize this thing. All right, I got this square root of 5x. I want that out of there. So just multiply it. So top and bottom by the square root of 5x. So the square root of 5x.
Would they cancel each other off?
So here's what I get. I get 7 times the square root of 5x is just 7 root 5x. And then on the bottom, I get this x. I'm going to put that guy in blue. And now what happens when you take root 5x times itself? Root 5x. What do you get? 5x. So you get that times 5x. So that's what I have circled here. That's this guy. So root 5x times root 5x is 5x. And then last but not least, well, we can simplify that. This is 7 root 5x over x times 5x is just 5x squared. Okay. This is inside of a square root. This is outside of a square root. They do not reduce each other or anything. This is your final answer. How are we doing with that? Questions? So far, so good? All right, so let's work on what to do if you have a cube root or a fourth root. Okay, this is where it gets a little tricky, so I hope we're paying attention and writing notes down. If I take a look at E, I now have a cube root. Okay, so I have a cube root of 5 over 4. Well, that's the cube root of 5. And then that's the cube root of 4. Right? Well, think about 4. If I broke down 4, do you guys agree that's like 2 and 2?
Yes.
Well, I don't have enough 2s to get rid of that guy. Right? How many more 2s do you guys need?
Just 1 and there's a 5 above.
Yeah, you just need 1 more 2. Right? So that's how I rationalize a cube root. If I multiply top and bottom by the cube root of 2, that's going to give me 1, 2, now 3 2s. Okay? So on top, I get the cube root of 5 times 2 is the cube root of 10. And now on the bottom, let's just kind of get rid of those guys. 4 times 2 is 8. Well, what is this? What's the cube root of 8? That's just 2. If I break this down, again, that's 4 and 2, 2 and 2. So usually what I do is I'll go from this step right to here so that I have the cube root of 10 and then over just 2.
You could say it's pretty rational.
It is pretty rational, yeah. So I got the cube root of 10 and then all over 2. And the idea is I had 2 2s to start. I had 4. 4 is 2 2s. I needed one more to make a group of 3 is the idea. Questions, y'all? All right, let's do a couple more here. So I got F. I have the 4th root of 1 over 27. Okay, so if I write this out, this is the 4th root of 1 over the 4th root of 27. And let me change this marker because it's dying here. Yes, good shot. All right, let's look at this 4th root of 27, and let's look at the 4th root of 1. What do you guys think the 4th root of 1 is?
1.
That's just 1. So that simplifies the 1. And now look at 27. Think about how to break down 27. 9 and 3, 3 and 3, right? Look at how many 3s I got. How many 3s do you count? I got 3 3s. Well, how many do I need for it to disappear?
4.
I need 4. So how many more do I need?
1.
I need 1 more. So I'm going to multiply top and bottom by the 4th root of 3, top and bottom. Does everybody understand why I'm choosing just 1 3? I broke down 27 to 9 and 3, 3 and 3. I got 1, 2, 3. I needed 1 more to make a group of 4. So final answer, I'll have to write here. 1 times the 4th root of 3 is the 4th root of 3. And on the bottom, now I got my 4 3s, right? I write it 1 time. So final answer is the 4th root of 3 over 3. How we doing? Questions? All right, let's try this again here, because this is where it gets kind of tricky. A little tricky. I got 10 over the 5th root of 16. Okay? First thing I look at is, well, 16. Let's break this down. 4 and 4, 2, 2, 2, and 2. I got 4 2s, right? But I need how many?
4.
I need 1 more. I need 5 altogether. So I need 1 more 2. So that's what I'm multiplying by, the 5th root of 2. 5th root of 2, top and bottom. Separate this here. So 10 times the 5th root of 2, that's 10, 5th root of 2. And now look at all these 2's I have. I got my 5 2's I write at 1 time. Okay, so I've just rationalized it by multiplying by what it was missing. It needed 1 more 2. Now, if I circle this and I put this in my method, guess what?
Reduce.
That's wrong. Yep, I got to reduce it. So the 10 and the 2 reduce. R for you pirates out there. So I get 5 and then the 5th root of 2. Woo! You want to do H?
Yes.
Do H real quick. H looks like a fun one. Any questions? Is it making sense, guys? Give me a thumb. Where are we at here? I got 2 cameras on. Where are your thumbs at, guys? No thumbs. People in class, thumbs, thumbs, thumbs. No sideway thumbs? Okay. You have a question? Thanks, Riley, for the thumb.
I just hope, like, when you do, like, say example, you get, like, 2. Oh, because it has to be the same number as the one you're trying to get another one.
Yes.
Oh,
So
okay,
here
that
we
makes
broke it
sense.
down in a bunch of 2s. We needed one more 2. You know. Well, let's look at the last one here. Holy cow! 7th root. OMG. Now, I want to break this down. 8 is 4 and 2, 2 and 2. So I got 3 2s here, right? How many do I need though?
7.
I need 7. So if I have 3, I'm missing how many? I'm missing 4. 4 of them?
Mm-hmm.
All right. So this is what I do. So I know I need a 7th root, and I need 4 2s. That's 2 times 2 times 2 times 2. Now, is this going to be this hard on the test or quiz? No, I wouldn't make it this hard. But this might help somebody understand what we're doing. All right. So this, you guys agree, 2 times 2 is 4, times 2 is 8, times 2 is 16. This represents 16. So that's what I'm multiplying top and bottom by, is the 7th root of 16. 16 again is 2 times 2 times 2 times 2, or 2 to the 4th. Okay. So on the top, I get that 7th root of 16. 1 times that is that. And on the bottom, look at all my 2s now. I got my 7 2s. There's nothing else I can do. This 16's on the inside of the root. This 2 is on the outside. They don't reduce each other. That's my final answer. Now, would I assign this one? No, probably not. Not on a quiz or test. That one's a little tricky. Questions on what I'm doing? The idea again is just look at the index. Look at what you're trying to find. And then figure out how many you got versus how many you need. And that's what you're rationalizing by, top and bottom. All right, we got a few more left. Not too many. Not too many. All right, so conjugate. That's a fancy new word. Conjugate. Here's the conjugate. Here's the idea. Conjugate means if you have A plus B, then the conjugate would be A minus B. So it's basically the opposite in between. If you see 2 plus root 3, then his conjugate is 2 minus root 3. So in B, if I have root 7x minus root 3, the conjugate is root 7x plus root 3. Okay, and we got to know the conjugate so that we can rationalize when you have like a binomial on the bottom. Okay, so in example 3a, I have 5 over root 3 plus 2. And we want to get rid of the square root of 3, right? We don't want it on the bottom. But the bad thing is if I multiply top and bottom by root 3 there, it's not going to eliminate that root 3. I will get root 3 times root 3 is 3, but then I would get 2 times root 3, and now I'm stuck with this 2 root 3 on the bottom. This is where we use the conjugate, okay? So we take a look at this guy right here, and we need the conjugate. So what's the conjugate of root 3 plus 2? So I'm going to multiply top and bottom. Michael said that was root 3 minus 2. And if you do it to the bottom, you got to do it to the top to keep it equal. Okay, so I'm going to do the top here in purple. I'm going to take this 5 times each one. Remember, numbers on the outside work with numbers on the outside, and numbers on the inside work with numbers on the inside. So 5 times root 3 is just 5 root 3. And then 5 times negative 2 is negative 10. So that's pretty easy. And now on the bottom, I'm taking this binomial times this binomial. I'm taking 2 times 2. Well, 2 times 2 is 4, right? And there's a 4-letter F word you're allowed to say in math class. And we got FOIL. First, outers, inners, last. Okay? We know not to say that bad word, right? And we know not to say fire. We talked about that the other day, right? Don't say fire in math class because then everybody thinks there's a fire. So I take root 3 times root 3. I get root 3 times root 3 is just 3. And now I take root 3 times negative 2, and I get negative 2 root 3. Remember, numbers on the outside multiply numbers on the outside, and so on, yeah. Missing the good stuff, though. Hurry up. And then I take the 2 times the root 3. That's positive 2 root 3. And then last but not least, I got 2 times negative 2 is negative 4.
That's a lot.
Seems like a lot. Not too bad. All right, let's take a look at what happens. On the bottom, you see what happens? Your outers and inners, your OI, this is O, this is I, this is F, this is L. Your outers and inners will cancel, right? And now we just put these two guys together. 3 minus 4 is negative 1. So I've totally gotten rid of that square root. Look at that. Okay, and the last thing I would probably do here just to simplify, I have both of these divided by negative 1. I can just switch the sign. So it's 5 root 3 and then plus 10. So the idea is I'm dividing both by negative 1. So final answer, 5 root 3 divided by negative 1 is negative 5 root 3. And negative 10 divided by negative 1 is positive 10. So that is, again, rationalizing when you have a binomial. Okay? Let's see that one more time. Which one do you want to do? Let's do C real quick. Is C okay to do?
Yeah.
And then if you want to see the other one, we can. All right. So anytime I'm rationalizing the denominator, I like talking like the terminator. Do you guys know the terminator? Yeah. My son came home the other day from daycare and he said, I have a headache. Maybe it's a tumor, not a tumor. I said, what are you talking about? Where'd you learn that from? And he said one of his friends had just watched Kindergarten Cop. You guys seen that? So I had to show him the Kindergarten Cop. He goes, I have a headache. Quiet. I have a headache. And the little kid goes, maybe it's a tumor. And he goes, it's not a tumor. It's not a tumor. Yeah? Oh my gosh. So we need to multiply this guy. We need to rationalize the denominator. It's funner if you talk like the terminator. Yeah. We need the conjugate. Do you guys know what the conjugate is? What do you have for the conjugate? What's the conjugate of this guy here? You guys don't even know who the Terminator is, do you?
I do.
Arnold Schwarzenegger, yeah? Remember that guy? Oh, man. So we got the conjugate is 3 minus root 5. Was that good? Was it a good?
Yeah. I know.
It was pretty good? It's not a tumor. No, not. So I'm going to multiply top and bottom by this conjugate. Okay? So I'm multiplying top and bottom by 3 plus root 5. Now, unfortunately, I'm going to have to FOIL the top and FOIL the bottom. No big deal. Let's So we're going to FOIL. I'll do the top one in purple again. Some days this thing works, and other days. All right, so here we go. So I'm going to FOIL. Root 7 times 3 is not the square root of 21. It is just 3 root 7. Root 7 times root 5 is the square root of 35. 2 times 3 is 6. And 2 times root 5 is not the square root of 10. It's just 2 root 5. So that's the top. If you want to change the order, that's fine, but it's not going to change the answer at all, so I would probably just leave it. And now I'm going to do the bottom. So I got 3 times 3 is 9. I got 3 times root 5 is 3 root 5. And now I got negative root 5 times 3. That's negative 3 root 5. And then negative times a positive is negative. And then what's root 5 times root 5? Root 5 times root 5 is just 5. Outers and inners are canceling. That's why we use the conjugate, because we wanted one to be a minus and one to be a plus, so those cancel. Okay? And on the bottom, I just simplified. 9 minus 5 is 4. And on the top, I have this big, long. Again, you can change the order. It's not going to matter in which order it is. There's nothing really you can do to simplify this thing. You can't combine the tops because these are all different square roots. So that's quiz or test. Am I going to make it that hard? Nah, it'd probably be like more like number 3A or 3B would be more like it. But this is as nasty as you could possibly see.